to do. And this will probably be most helpful if you have a straight edge. So I'm going to throw some straight edges at you real fast. On the back of the paper, I'm so sorry. On the back of the paper, use this straight edge to trace like the top and the bottom and make parallel lines. Okay? We're just going to make some parallel lines. Make some parallel lines. Okay, let's call that line what? What should we call it? Line F and line A. Okay, sorry. Oh, I didn't make them lines yet. Let me make them lines. There we go. We've got some parallel lines. I just use my straight edge to make them. Now what I want you to do is I want you to take a straight edge and I want you to make a transversal. What is a transversal? It's a line that intersects how many? Two or more lines at different places. Okay, there's one more thing about this. I said to make parallel lines, but if somebody were to look at my picture right now, they could not assume that these were parallel. Put the little arrows on it so we could let everybody know that these, in fact, are parallel lines. Okay. When we have parallel lines in a transversal, there are specific properties that our angles have, the angles that we've already learned about. There's some, what do they call them? There's theorems about these angles that you have to remember. So let me start out by, let's just number these real fast. 1, 2, 3, 4, 5, 6, 7, 8. I want you to look at any corresponding angles. So I'm going to take a color and I'm just going to highlight 2 corresponding angles. Can somebody give me one angle or one pair of corresponding angles? Yell it out.
2 and 6.
2 and 6. Perfect. 2 and 6 are corresponding angles. Now, if you already read the theorem, good for you. But if you haven't read it, let's just like use our guesstimation powers. What do you think I'm going to tell you about these angles? What do they look like? They are congruent. If we have parallel lines and a transversal that cuts parallel lines, corresponding angles are congruent. So I'm going to put an arc in there that shows that corresponding angles are congruent. Is there anything else on this picture that, just guessing, looks like it might be congruent to angle 2 or angle 6? Okay. 7 and what? 3 and 7. You guys think 3 and 7 are also congruent? There's actually something you've already known prior to today, that 3 and 7 are congruent to 2 and 6. Why is 3 congruent to 2? They're vertical angles. And then 7 is congruent to 6. They're vertical angles. So 3 and 7 are also congruent to 2 and 6. They're all congruent. Okay? All right, so now comes the trickier part. Let's see if you can figure it out. Angle 1, I want to compare to angle 2. I want you to look at angle 1 and compare it to angle 2. And I want you to tell me anything that you can come up with by saying angle 1 and angle 2 in the same sentence or statement. Are they congruent? No. What can we come up with about angle 1 and angle 2? Lynn? Yeah, angle 1 and angle 2 are supplementary. Do you know what the pair of angles are called when they make a line? They're next to each other. They add up to 180 degrees and they're adjacent. They're called linear pair. Which means that they are supplementary. Which means they add up to be 180 degrees. What is angle 1 up here congruent to? What's angle 1 the same as? 4? Why? Because they're vertical angles? Is that it? What else is angle 1 congruent to? Cameron. Angle 5? Why would angle 1 and angle 5 be congruent? They're corresponding. And when we have parallel lines and it's cut by transversal, corresponding angles are congruent. Was that you too, David? Thank you. So what would also be congruent to angle 1? Angle 8. So here's another theorem that's on the other side. What kind of angles are 1 and 8 together? Ooh. What are they? Alternate exterior, yes. So there's another theorem on the other side that says alternate exterior angles are congruent. How about on the interior? Do we have any angles on the interior that look like they are congruent? 4 and 5 are congruent? Or 3 and 6 are congruent? What kind of angles are 4 and 5? Alternate interior. They're on the inside and different sides. Okay, and then the other angles we were talking about on Friday were consecutive interior. So consecutive interior would be like 4 and 6. What can we say about angles 4 and 6 together? Maggie? They're not a linear pair.
They're not the same.
They are supplementary. They are supplementary, but they're not a linear pair because they're not next to each other. But they are supplementary. So angle 4 and angle, what did I say, 6 are supplementary. And you can see that from our picture that we've drawn and highlighted the different colors of which ones were congruent. Okay. So I'm going to turn it back over. Those theorems that we just talked about at some point are all written here. So corresponding angles theorem says have parallel transversal, check. Then corresponding angles are congruent. All of these you have to start with 2 parallel lines cut by transversal. If they're not parallel, you can't do any of this stuff. Alternate interior angles are congruent. Alternate exterior angles are congruent. And then consecutive interior angles are supplementary. And then you should already know linear pair, they're congruent, and vertical angles are congruent. So we've got 3 examples. 5 examples. I mean, there's like 5 problems here. Use a diagram to determine what numbered angles have a measure of 120 degrees. So you see our 120 degrees is right here. Let's see if we could say which angles are 120 degrees by what. It says explain how you know. So, measure of angle, which one? Angle 4 equals 120 degrees. By what? Do you know, Alex? It's not definition. It's called the vertical angles congruence theorem. So I'm going to write vertical angles. It's called the vertical angles congruence theorem. That's written in our notes from last chapter. But I like to write it short. I like to write vertical angles are congruent. There you go. It's the vertical angles congruence theorem. So what other angle is 120 degrees? Lynn? Angle 5, why? Oh, by angle 4 and 5, is that what you're saying?
Yeah.
So I'll say alternate interior angles with angle 4. What's a different reason why angle 5 could be 120 degrees? Corresponding with that 120 that's given. Yeah. Is that it? Is that the... Here, I can color them so we can see. Is that the only ones that are 120? What else? Somebody else. Jay, do you know? What is 120 degrees that I haven't colored pink yet? Angle 8, okay. And why did you think that? Okay, vertical from 5. What if I wanted you to talk about it with the original 120? How does it compare to the original 120? What kind of angles are those? Yeah, I'm going to write it that way just so we like change up our answers a little bit. Alternate exterior angles with angle, or with 120 degrees. There you go. Okay, here we're going to solve for the missing variable. This one might be a teeny tiny little bit confusing because there's this random 4 right here. It took me a moment to figure that out. So the reason why the 4 is here is because if you look at 115 degrees and you look at x plus 5, there is not a theorem for these two angles. There's not a theorem for 115 and the x plus 5. Those aren't a thing. So what we have to do is we have to figure out angle 4 first, and then we'll use angle 4 and the x plus 5 because those are a thing that have a theorem. So what is angle 4? 115 degrees, because why? Vertical angles are congruent. Okay, so once we know that measure of angle 4 equals 115 degrees, what can we say about measure of angle 4 and the x plus 5 degrees? Alex? Because they are supplementary. Consecutive interior angles theorem says we can do 115 plus x plus 5 equals 180 degrees. That's the consecutive interior angles theorem. Theorem. That's how you spell theorem. Theorem. I spelled it wrong. Theorem. Okay, so I'm just going to solve this equation. We'll add 115 and 5. So x plus 120 equals 180. X equals 60. This is solve for the missing variable, so I'm done. When you guys solve for x, x is not degrees. X plus 5 is degrees. What's the measurement of this angle right here? That's 65 degrees, but my x is just a 60. Okay, how about example B? What kind of angles are these? Are these a thing? This angle and this angle, are they a thing? They're on either side of the transversal, so that would be like alternate, but one is exterior and one is interior. That's not a thing. So what should we do? Maggie, what do you think?
Would they join supplementary thing or no?
They would, but I'm gonna try to get there, like if we were doing a proof where you can't just jump to the fact that you know these are supplementary.
Yeah.
Okay? So I'm going to try to use things that we know to get there. Kind of like what we did here where I told you I put a 4 in there so you'd know you'd have to find 4 first. Here something. So I'm kind of leaving it open. What can we jump to? Jesse, what do you think that I could find the measurement of any angle here before I can put these together? Like find another measurement there. There's not really numbers here. I'll put some numbers in there so you can tell me which one you're talking about. There's lots of different answers you could give me.
Yeah, I know. That's why I don't know for one. With the 2x, can't you say that is 1 considered like part of the 2x?
So angle 1 and angle 2x are supplementary.
Yeah.
But angle 1 is what to 120? Alternate exterior. So angle 1 is what to 120 if they're alternate exterior? What are they? If you guys feel like you know how to do this, what you should do is find the answer with reasons to see if you can do it without my help.
You said the measurement angle 1 and 120?
Yeah. So measurement angle 1 is 120 because, I'll say by alternate exterior angles, because they're congruent. They're alternate exterior angles. So now going back to what you said before, Jesse, 2x and 1 are supplementary because they're a linear pair. Actually, is the definition of linear pair or linear pair postulate? Linear pair postulate. And so now we have an equation we could solve. We could take away 120 and I get 2x equals 60. So x is 30. It's not degrees. Okay, I want you guys to try these, C and D. On C, I've given you an angle that you have to find first. On D, I gave you options. So you don't necessarily have to find something first on D. lot of you are doing easy, no problem solving the equation, but can you tell me why you're allowed to set certain things equal to each other? Can you tell me the reason, which is the hard part, where if you keep avoiding it, you're never going to learn how to do it. Tell me why you're allowed to do